practical is to determine the amount of aspirin in a given solution pH-metrically. So here you have to determine the concentration of aspirin, okay, using the pH meter. So aspirin is acetyl salicylic acid. It is a weak acid, and that's why you can titrate it against alcoholic KOH, which is a strong base. Okay, so it's a normal acid-base titration wherein the neutralization of aspirin would occur and you will be getting one endpoint. So the requirements are, first of all, you require the aspirin sample solution, 0.1 normal alcoholic KOH as a titrant. Why alcoholic? Because the aspirin over here is being dissolved in an alcoholic medium. Okay, because it is having high solubility in the alcoholic medium. So since the sample solution is being prepared in an alcohol, the titrant is also taken in an alcoholic medium, right? So the medium, or you can say the matrix of sample as well as the titrant would be same. Then you require the glass electrode, okay, glass membrane electrode, or you can say pH electrode you require. You then beaker and glass rod is being required. Let us now see the procedure. So first of all, you need to take 50 ml of the given solution of aspirin in a beaker, and then you need to titrate it against 0.1 normal alcoholic KOH. So take alcoholic KOH in a burette and start adding 1 ml of alcoholic KOH, and at each addition you need to find out the pH values. Okay, and that pH values you have to note it down. So in this practical, you have to go for two sets. The first set would be the pilot set and the second set would be the micro set. So now let us see first of all the pilot set. Okay, so you have to take alcoholic KOH in the burette, right? So first of all, measure the pH at zero addition of alcoholic KOH. Okay, so put your glass membrane electrode into the sample solution of aspirin, determine its pH, and the pH you can see over here is 4.51. Okay, it is weak acid, that's why the pH would be acidic in nature. Okay, then you have to add 1 ml of alcoholic KOH into the beaker, stir it properly, and then again find out the pH. So pH now is 5.46. Okay, then you have to add another 1 ml, find out the pH. In the similar manner you need to find out the pH. Okay, and simultaneously also you need to determine the delta pH. Okay, that is the difference in the two different pH values. So there would be no difference in the first value. For the second one, it would be 5.46 minus 4.51, that would give you 0.95. Then for this value, 8.49 minus 5.46 would give you 3.02. So in this way you need to find out the delta pH values. Then you can see over here the maximum delta pH value is obtained at 2 ml, right? 3.03 is maximum out of this thing, right? So you are getting the jump at this point, or you can say you are getting the jump between 1 ml and 2 ml addition of alcoholic KOH. Okay, you can see over here there is a major difference in the pH. pH over here is 5.46 and over here it is increased to 8.49, right? So aspirin is being neutralized, okay, because there is a major change in the pH. So the equivalence point, or you can say the end point, is obtained between 1 to 2 ml. Okay, so from the pilot set you can get to know that where the endpoint would be obtained. So you can see that the endpoint would be obtained between 1 to 2 ml of alcoholic KOH. So now using this readings, you also need to prepare a graph of pH versus volume of KOH which is being added, right? So this values you have to take as y-axis, and on x-axis you have to take the KOH which is being added to it. So initially, as we know that the pH would be lesser, right? pH is lesser. Then as the neutralization reaction starts, the pH would gradually increase. Okay, and at the end point, the pH would increase very rapidly. You can see over here, very rapidly the pH increases, right? And then the pH would again increase slowly. You can see that then from here, once the equivalence point is being obtained, the pH would increase slowly, right? So the nature of the graph would be like this, and over here you will be getting your end point, right? So over here we know that our endpoint is between 1 to 2 ml, right? So in the next set, which is the micro set, you have to take 10 different readings between 1 to 2 ml, right? You have to add 0.11 ml of alcoholic KOH and you have to find out the exact end point, right? You have to determine the correct end point. So this is the second set, which is referred to as micro set. So again you need to take 50 ml of the alcoholic uh, solution of the aspirin, right, in a beaker, and then start from the beginning. Find out the pH at zero addition of alcoholic KOH, it would be 4.59. Then add 1 ml, right? It would be this much. Then from 1 ml, you have to add 0.11 ml of alcoholic KOH up till 2 ml, right? And then you have to add 1 ml. Clear? So from the pilot set, we get to know that our jump is over here at that is at 2 ml. So maximum delta pH is obtained at 2 ml. So we have to determine the endpoint, which would be between 1 to 2 ml. So that's why we take 10 different readings and we determine the exact endpoint. So for this, you have to find out the delta pH value, delta V value, okay, that you also have to write down. Then you have to take a delta pH upon delta V, okay. So now over here you can see that the maximum delta pH is being obtained at 0.65. I mean, it is obtained to be 0.65 and it is obtained at 1.8 ml, right? Check the values between 1 to 2. Okay, if you see all of these values, I mean, from starting from 1.1 to 1.9, all of these values, 0.65 is the maximum, okay, that you can see over here also. Out of all of this value, 6.5 is the maximum. So this is our exact endpoint where the neutralization of the aspirin has been completed, right? So 1.8 is our exact endpoint, right? So from microset, you have to prepare a graph of delta pH upon delta V versus volume of KOH added. So this versus this, right? So you will be getting a peak in this graph. From the peak, you have to draw a straight line. Whatever the volume you get over here, that would be your end point, okay. VML for us it would be 1.8, okay, because you can see that all of out of all of these values, maximum is 6.5. So this, the peak would be I mean the peak at peak, the maximum value would be obtained, and that would be at 1.8 ml, right? So from the graph you can determine this thing. Now let me show you this graph. It is this one, okay. This graph is drawn using the same readings, and you can see that maximum is being obtained at 1.8 ml, okay. So this is your endpoint. So using this graph you can determine your endpoint, okay. And this is this graph is this one, and you can see in this the nature of the graph, okay. It is sigmoidal shaped, okay, wherein initially the pH would be lesser and then it would increase, okay, and at the equivalence point it would increase rapidly and then it would increase slowly. Clear? So in this way you need to draw the graph from both the sets. So now we are having the equivalence point. Using this you can do the further calculation. So over here you see in the results you have to mention the endpoint equals to 1.8 ml, right? Then you have to find out the concentration of aspirin. Okay, you have to find out the normality and you have to find out the concentration in grams. Okay, and we know that 1000 ml 1 normal KOH equals to 180.2 gram of aspirin. Okay, so this is the equivalent weight for the aspirin, that is acetyl salicylic acid. So this is the calculation. So concentration of aspirin, you have to find out the normality first. N1V1 equals to N2V2. Okay, take one as aspirin, another as KOH. So the normality of aspirin is N1. We have taken 50 ml of the sample. KOH we have taken 0.1 normal, okay, which is your titrant. You are getting the endpoint at 1.8. Okay, by the calculation, the normality is obtained to be 0.0036 normal. Then you have to find out the amount of the aspirin, okay, in grams. So for that, we will be using this method. Okay, 1000 ml 1 normal KOH equals to 180.2 gram of aspirin. Put the endpoint 1.8 ml 0.1 normal KOH equals to how much? So do the calculation. The answer you got is 0.0324 0.03243 gram of aspirin in 50 ml. Why 50 ml? Because we have taken 50 ml of the sample for the titration. Now you have to convert it into gram per 250 ml. So multiply it with 5. You will be getting 0.16 gram of aspirin in 250 ml. Right now, if you want to further convert it into gram per 1 liter, then multiply this value into 4. Okay, multiply this value by 4 and you will be getting in gram per liter. Okay, so your final answer should be either in gram per 250 ml or in gram per liter. So this is the way in which you can carry out your calculation. Okay, so basically in this you have to perform two different sets. From the pilot set you can get an idea that where the equivalent point could be, and then from the micro set you can get the exact end point. Okay,